In this example, we show how to perform factorial analysis in ILLMO. And let's start by looking at the example data that Andy Field uses to introduce the topic in his book. What he notices, this is an example where there are 6 experimental conditions indicated by the first variable, but they arise by combining 2 factors, meaning taking all combinations between the gender of a participant in an experiment, which is either male or female, and the alcohol consumption, which is actually 0, 2, or 4 beers. And the dependent variable is the attractiveness of the partner that the person is talking to at the end of the evening. And the question is whether not only whether the condition has an effect on the attractiveness, but trying to understand how each of the individual factors have an influence. Now, traditional factorial analysis cannot handle factors that have more than 2 levels. So gender has 2 levels, male, female, but alcohol has 3 levels. So the way they approach that is to introduce what is called dummy variables. So you can code the 3 conditions by having one variable that says whether you drank 2 glasses of beer and another variable that says whether you drank 4 glasses of beer. Now we can read this file. So the condition is 1 out of 6. So the dependent variable is attractiveness, and the 3 factors are gender, alcohol, 2 glasses, alcohol, 4 glasses. Now what makes it into a factorial analysis is that we're not only interested in the effects of each of these factors individually, but also in what is called their interactions. For instance, we also want to understand whether the effect of 2 glasses of beer is different for male or female. And the way to do this in factorial analysis is to also include a factor which is the product of these 2. So we can add two-way interactions, which will mean that while the original multiple regression had 3 factors, now 3 factors for interaction have been added. Now, one of these factors, meaning interaction between 2 dummy variables, is always 0, so we can remove that safely. Now, what we see is that the first 3 values are for female, the last 3 values are for male, and then that in case of no alcohol consumption or only 2 glasses of beer, seems to be an effect that the attractiveness of the partner is higher for males than for females. But the most obvious effect in the data is that the effect of drinking 4 glasses of beer seems to be much bigger for males than for females. And that's the effect that we're trying to bring out. Now, one easy way to try and see which of these factors, both the main effects and the interaction effects, is useful for predicting the data is to use multimodal regression, because then we're performing a lot of different multiple regression at the same time, and we see that the one with the highest weight, which is here about 50% of the weight, actually goes to the case that only has 2 effects. So the main effect of the first variable, which is male or female, and only an interaction effect between what we were always expecting between male and high levels of alcohol consumption. So knowing this, we could say, well, probably a fair model is going to be one in which we exclude the other effects, which we can do by just turning them into 0. That indeed decreases the AIC substantially, so this is indeed a much better model. And what it does is it simplifies the data before. Say I have one level for female and one level for male, but with the exception of the high alcohol case, which is being reduces the attractiveness of the dependent variable. So we could have a look at this interaction effect and create log likelihood, and we see a very significant factor.